gateway will act as single entry point for all backend APIs. Okay. Backend APIs will contain business logic. We can say backend REST APIs. Backend REST APIs will contain business logic. Service registry is used to maintain list of services available in our application. Backend APIs will register with the service registry. Our backend APIs should register with the service registry. Should register with service registry. API gateway will act as single entry point for all backend APIs. API gateway contains filters and routings. API gateway contains filters plus routings. Filters are used to validate the request and response. Filters are used to validate the request and response. Filters plus routing. Filters plus routing. Okay. Filters are used to validate request and response. Filters are used to validate request and response. Routings are used to route the request to particular backend API. Routings are used to forward incoming request to backend API. Incoming request to particular backend API. So like this we are going to follow microservices architecture to develop our application. Service registry. Now here we can say that service registry means we can say Eureka. Service registry Eureka. API gateway will act as single entry point. Cloud gateway. Spring Cloud gateway. Spring provided one gateway which is called Spring Cloud gateway will act as single entry point for all backend APIs. See here, backend REST APIs will contain business logic. Service registry is used to maintain list of services available in our application. Our backend APIs should register with Eureka server, that is service registry. API which registered with Eureka server is called as Eureka client. API which registered with Eureka server is called as Eureka client. Now, API gateway will act as a single entry point for all backend APIs. So if any request coming to our application, that request should pass through API gateway. API gateway will contain filters part and routings part. API gateway will contain filters part and routings part. Filters are used to validate the request and response. Filters are used to validate the request and response. Routings are used to forward incoming request to particular backend API. Incoming request will be there. That incoming request will be forwarded to particular backend API. Who will do that concept? Who will do that forwarding concept? API gateway will do by using routing technique. Now look at this diagram and read these points. You will get the clarity. We have developed several backend APIs. Backend APIs will contain business logic. Service registry is used to maintain list of services available in our application. Our backend APIs should register with the service registry. API gateway will act as a single entry point for all backend APIs. API gateway contains filters plus routing. Filters are used to validate the request and response. Routings are used to forward the incoming request to particular backend API. Are you clear with my points? Are you clear with my diagram and my points? So how a microservice based application will be developed? Microservice application will contain front-end application, backend APIs. To manage the backend APIs, API gateway will be available. So to show you all the APIs and API URLs, service registry will be available. Now, API gateway is one project, service registry is one project, all the APIs are separate projects. So every project is going to run in the separate server. Plans API will run in one server, user management API will run in one server, AR API will run in one server, DC API will run in one server, ED API will run in one server, CO API will run in one server, reports API will run in one server. So total there are 7 APIs are available. 7 APIs will run in 7 servers. Nothing but 7 EC2 instances are required to run these APIs in the cloud. There are 7 APIs available. In order to run the 7 APIs, I need to take the 7 EC2 instances. I need to take the 7 EC2 instances. Are you clear with my point? In order to run the 7 APIs, I need to take 7 EC2 instances. And the service registry should be there. Service registry is a separate project. It should run in one instance. And the cloud gateway is one project. It should run in one instance. UI application is there. It should run in one instance. Now think about the infrastructure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 servers are required to run this application. Because we are following the microservices architecture. If it is a monolith, single project will be available, single war file will be available. Now how many war files we are going to get for this application? API gateway 1 war file, service registry 1 war file, backend API is 7 war files. Total 9 war files we are going to get. 9 war files we need to deploy into 9 servers. That means you need to take 9 EC2 instances in the AWS cloud to deploy your application. That is how it is going to happen in the real time. As it is difficult to manage this infrastructure and all, companies are looking for AWS and DevOps engineers. They will take care of the deployment activities and infrastructure activities for our project. That is the reason nowadays AWS and DevOps is having a lot of demand in the market. We are developers. We are developing our project. Then what about operations? Who will prepare the servers for our applications? Who will prepare the deployment activities for our application? That will be done by DevOps and AWS people. We are the developers, we will develop the code, we will test the code, we will keep the code into repository, Git repository. Once you store your code into Git repository, then operation team is going to start. They are going to take your code, they are going to set up the infrastructure, and they are going to deploy the application. It is not easy to maintain the infrastructure. That is the reason companies are going for a cloud infrastructure. Companies are using the cloud infrastructure and they are setting up the infrastructure in the cloud. They are deploying the applications in the cloud so that cloud provider can manage the infrastructure. We will just pay the money for the infrastructure and that will be managed by the cloud provider. That's why AWS is having that much demand in the market. Now, guys, tell me, can we manage this infrastructure manually? We can do, but we need to purchase 9 computers, 9 servers we have to purchase, database we have to purchase, power we have to purchase, security, AC, room, data center, lot of things, and we need to recruit the employees, we need to secure these things. High speed internet is required, 24/7 power backup should be there. One server is required to store our computers. There should be one networking engineer to set up the network for all the computers. Data backup should be there. Database server should be there. DBA is required. Load balancers we have to configure. After the development, it is very difficult to manage the infrastructure. We have developed our code, but sending this application to the production requires a lot of operations. To send this application to the client, we need to deploy with all these applications ready and working. We need to set up a lot of infrastructure. Setting up the infrastructure manually is very time taking and costly operation. That's why companies are preferring AWS cloud. I have taken 20 classes for you to tell you what is AWS cloud, why we are going for AWS cloud. Cloud database we are taking, so no need to do anything. EC2 instances we are taking, installing the server, deploying, so cloud provider will manage that. So our applications are going to be developed in this architecture fashion, guys. Microservices architecture will be available. Backend APIs, they will communicate with the database. Service registry, to register all the services, it is a DB of APIs, just all the API details it is going to show us. API gateway, it is a single entry point to manage the APIs. Commercial API gateway is also available. Google company provided one API gateway called APG. APG is one of the commercial API gateway provided by Google company. Here, our Spring framework also provided one API gateway for free of cost, that is called Cloud Gateway. When you go for Cloud Gateway, limited functionality will be available. When you go for APG, that is a Google provided API gateway, which is a commercial, that is going to have a lot of functionalities. Let us see what is this APG. What is this APG? API management given by Google. What is APG? APG is one of the API gateway given by cloud. APG is a platform for developing and managing APIs by fronting services with a proxy layer. APG provides an abstraction or package for your backend service APIs and provides security, rate limiting, quotas, analytics and more. So what all the services available in our application, all those services will be managed by APG API. APG is a cloud gateway. APG is a cloud gateway given by Google. APG is a software as a service, which is they are going to provide you the software as a service. It is going to maintain the environment, allowing it to concentrate on the building your services and defining the APIs to those services. The remaining security stuff, monitoring stuff, everything will be taken care by APG. That is a Google company provided APG. So that is a commercial API gateway. So here, for practice purpose, we are going to use free API gateway, which is Spring Cloud Gateway. Earlier, Joule is available, but Joule is outdated in the market, and Spring released their own API gateway, which is called Cloud Gateway. Understood my point? All of you? Now, anybody open for questions? You can ask me now. Yeah. Anybody having doubts can raise your hand.
Yes, Sami.
Yes.
This API gateway, right? The filters and routings. So here, exactly like filters, is it like the security or authentication and authorization?
Yeah, whatever filter is a program, whatever the authentication or authorization you want, your logic you can write inside that filter. Filter is a program. There will be a method. So whenever a request comes to the API, so that filter is going to execute. In that filter, whatever the logic you want, you can write that logic. Whether you want to do authentication or authorization, token validation, or whatever the request is coming, store the request data into database, store the response data into database. Whatever the common logic you want to do for all the APIs, that common logic we can cross-cutting logic. Common logic which is required for every API can be implemented in the API gateway.
Okay. And sir, but here we have 7 different APIs like plans and user management. So practically every API would have different security authorizations, right?
No, I mean, why we need to have it when these APIs are belongs to same application? Security means whether we need to allow the request to access our API or not.
So, but there are different there are different rules, right? So some of like at a particular level, some of the employees have access to CDCR, the DCM.
Rule management, you are asking that.
Yes.
Authorization. Yes, even that also can be implemented in the API gateway. For every backend API, we can write a separate filter.
So, sir, what I mean to say is there are 3 roles, right? A user role and admin role. All right. So
Yes,
a person
right.
who has an admin role will have much more rights and than a user role. So what I mean to say is here, those say for example, just a hypothetical scenario, this user management. Somebody having a user role can access, but you know the reports API can only be accessed by the admin. So how do we configure this API specific security?
Yes. We can do that. We can configure that authorization by using security technique. We can configure which user should allow to access which API that we can manage. Role-based authentication we can configure.
So role-based authentication, we do it at the gateway level?
Yeah, we can do it at the gateway level also. Yeah, there is a concept called load balancing. One API you can run with multiple instances. Now you are saying that my plans API may go down due to some network outage or due to some power problem or due to out of memory issue. There can be some reason where my plans API is down. It is not responding.
Yeah, and these APIs are interdependent, right? Because they extract
Exactly.
data from AR.
Right. Yeah,
So,
I understood. I understood. What we do in the real time is whatever the API is there, which is very crucial to execute our application, those APIs we are going to run with multiple instances. That means load balancing we are going to do for that API. So if one instance is down, other instance will be up and running.
so there's some concept called historics, right?
That is circuit breaker. Circuit breaker means when your main logic is not executing, then we need to execute the fallback logic. Your API is down, it is not able to receive the request. Then what is the point of circuit breaker?
So the last question is the service registry, right? We call these APIs as Eureka client. So there's something called Eureka server also.
That is what service registry. Eureka server, service registry, both are same. Service registry application, the application which is we are considering as a service registry, that application will use Eureka server.
So when we speak about microservice architecture, is it only one type of architecture or there are different types of microservice architecture?
Architecture, there is no specific architecture for the microservices. Some people may not use service registry. Some people may not use API gateway. Some people will use only service registry. Some people will use only API gateway. Some people will use both. That's why that microservice having different styles. It depends upon your project requirement. You can customize it.
Right. So when they ask like what is, because there was an interview question like what is this microservice architecture you follow? So then we explain the whole flow.
Yes. You need to explain. You can say that in our project we have both service registry and API gateway. This is the generalized architecture for the microservices. For microservices, there is no fixed architecture. Most of the people will follow this architecture to develop microservices. Good. Fine, guys. Next one. Anybody else having a question on this microservices architecture? And what is the role of service registry? And what is the role of API gateway? I will implement a small project with this architecture diagram, guys, so that you will get the practical clarity on that part. All right. Yeah, Ratnaraju, what is your doubt?
Yeah, sir, I have understood that logic, sir, but this is not my question. My question is client pressure when it happens.
Yes, sir, I understand. Yes, sir, Ratnaraj, I understand. Today we are going to send a poster. We got one requirement for the people who are having the knowledge on only core and advanced Java. They are going to recruit those people. So today we will prepare a poster and we will send you so that you can forward your resume. Okay. We got the requirement from a company. Last Saturday I got a requirement from a company. They are looking for the people who are good in core Java and advanced Java. If Spring Boot is not available also, no problem. They will take care of that. Okay, fine, guys. Good. With this, I'm stopping for today. We'll continue tomorrow. Tomorrow we'll do a small POC on this microservices architecture so that you will get the clarity. Thank you.
Sir, please give me preparation charges, sir.